Welcome friends. Myself Rahul Thakkar. I'm associated with LJ Institutes of Engineering and Technology. Now in this video we will understand the inspection of material through NDT by two different methods, namely pulse echo system and flaw detector method, with its advantages and applications. At the end, we will discuss the applications of ultrasonics in cutting and drilling. So, let us start with the first topic of today's session, that is pulse echo system. Pulse echo system is the most widely used ultrasonic testing method. Okay? It uses a single transducer for both sending and receiving the ultrasonic waves. For better contact between the surface and the probe, couplets like thin oil or glycerin is used. In this method, ultrasonic waves are sent at a given time interval from a pulse generator in the sample. As the wave passes through the top surface of the sample, there will be a pattern or peak on the oscilloscope screen A, as if there is no defect in the sample. Okay, so the peak of the reflected pulse will appear at a C. If the sample has a defect or a flaw, then wave will get reflected back and smaller peak will appear on the screen B. Let us understand this thing by some example. Consider this as a surface, okay, a rectangular body or some metallic object, for which you need to do some detection method. So consider this to be a probe which sends and receives. This is a transducer. Just assume this to be a transducer which sends and receives the signal or ultrasonic waves. Okay, so whenever, if you can see in this, there is, if you want to find out some defect in here, so over here this is surface A, this is surface C. Okay, so if you will place over here and move it forward like this, if there is no defect, then you can see the peak or a pattern will be generated at position A and C if there is no defect in it. But if there will be a defect, I have shown it over here. You can see if this is the defect. So whenever the probe is coming over here, okay, so the defect will be detected at a position D. A pattern or peak will be seen at this position. So by knowing the pattern or the peaks, you can easily estimate the defect. Let us understand this in a more clear way. You can see the figure over here. You can see the probe, the metal, and there is a spot in between that. Okay, and on the other side of the image there is a CRO screen. Cathode ray oscilloscope screen is there. On the screen you can see there are two peeps. Okay, so it is for this whenever this defect is not there. display showing the signal generated from the sound reflecting off back surface. Okay, the sound is being reflected from the back surface, that is C. Because there is no defect right now, you need to see, for this you need to see in this direction. In this direction, right now there is no defect. Sounding is being sent. So on this surface A, the first tip is there, you can see. Okay, and at the end, for the surface C, the another tip is there. You can see. Okay, in the figure. Now, whenever the defect comes, look at the figure. Okay, in between there is a defect. Okay, so in the CRO screen you can see that tip is there. Okay, so the display showing the presence of a reflected midway through the material with a lower amplitude back surface reflector. Okay, so this is how you can just estimate the defect. Now next topic is ultrasonic flow detector. So it is also known as a through transmission system. Okay, so through transmission system requires two transducers, one for transmitting and another for receiving the ultrasonic sound waves. The transmitted waves get reflected when they find a defect in the sample. The reflected pulse is received by the receiving transducer in the form of a sound wave and converted into an electrical signal and fed back to the CRO. You can see in the figure, the reflected waves are then amplified, and after amplification they are sent to the cathode ray oscilloscope. That is for the feedback. Okay? Then the time taken to come back, okay, for the time taken to come back the wave or the signal is noted by this, and exact size of the defect can be determined. So using this flaw detector method, you can estimate the size and the position both. In the pulse ecosystem, you can only find out the position. You cannot estimate for the size of the defect. But in this flaw detector system, you can estimate for both size as well as position of the defect. Okay, and let me recall it. Ultrasonic flaw detector system, it is also known as a through transmission system. Okay, so it is also known by the another name. You need to remember this because it can be asked in either ways. Explain ultrasonic flaw detector, or it can also say that explain ultrasonic inspection method by through transmission system. So this is the same thing called by two different names. Okay. Now let us discuss the advantages of ultrasonic inspection method. So first advantage is it is very cheap and it has a high speed of operation. Large size sample can be inspected in the very short time. Location, nature and size of the defect can be accurately determined. Now, with every advantages and possible desirable things, there also come some limitations. So there are the few limitations of ultrasonic waves or ultrasonic inspection method. So let us discuss about that. So first limitation is no permanent record of the defect can be obtained. It can be observed on the screen only. Only skilled and well-trained technicians can perform this testing. Okay, you need to require high-skilled laborers or technicians for this to perform this test. Now let us discuss the applications of ultrasonics in industries. So in the drilling and cutting. So in drilling technique, a tool driven by a ultrasonic generator is used. Okay. Abrasives like boron carbide and silicon carbides are used. Abrasives, what are you might be knowing about the abrasives? What are abrasives? Abrasives is a material that is used to sharp or finish a sample by rubbing, which leads to a part of sample being thrown away. That is the definition of abrasives. So in here we are going to use abrasives such as boron carbides or silicon carbides. Carbides are the very hard materials. Okay, so they are used in here for cutting the metals. A generator makes the tool bit to move up and down very quickly and forces the abrasive particle again each other, okay, again the material to cut, thereby removing some material from the surface. The same technique is used for cutting. Okay, in drilling and cutting you can use the same techniques by using the abrasives, and ultrasonic pulse generator is used to supply very high frequency to move these abrasive materials ups and downs, and thereby providing a cutting action. While they rub against each other, they cut onto the material, and thereby the material is thrown away. That's it for today, guys. Thanks for watching.